All right, today we're going to learn how to solve more trig equations, specifically ones that might fit the form of a quadratic. We'll talk about how to use what's called a u-substitution, and we'll look for greatest common factors with trig expressions. Okay, so u-substitutions. This is a technique that you might have seen before and we'll definitely use in calculus. When you see an expression repeated multiple times in an equation and it cannot be combined otherwise, sometimes it helps to replace the repeated expression with u. Okay, that's called a u-substitution. So let's take a look at some of these new equations. So it says solve each equation over the interval 0 to 2 pi with 2 pi excluded by factoring. All answers must be in exact terms of pi. So we're leaving our answers in terms of radians. So you'll notice here that we have three terms. We've got sine squared, sine to the first power, a constant, equals 0. So here I can't combine sine squared and sine, right? They have different powers, sine squared, sine to the first, and they're separated by addition or subtraction. So instead, if we wanted to look at this problem in a simpler way, we can use our u-substitution. So here we're going to let sine of x equal u, or u equals sine of x, whichever way you want to write it. Okay, so anywhere I see sine of x, I can replace that with u. So if this is sine of x squared, sine squared of x, this is the same as u squared. Minus 3 times sine of x, minus 3 times u, plus 2 equals 0. And now hopefully this problem looks more familiar. It's a quadratic, right? Might not have noticed that before, but this is a quadratic that can be factored. Okay, so this time we didn't need quadratic formula or anything crazy here, but sometimes you may need to do that. And now what we do is we can either solve each of these, which would tell me that u equals positive 2 and u equals positive 1 through the zero product property, and then we substitute back in our sine of x. So instead of u, we're going to say sine of x equals 2 and sine of x equals 1. Okay, so we take the inverse sine of both sides. We're looking at the values from 0 to pi. Where does sine equal 2? Well, that's undefined. There's no solution here, right? Sine is never equal to. Positive 1 is the maximum value for sine. But where does sine equal positive 1? We know from our unit circle, that's at 90 degrees, or pi over 2 radians. That is the only place sine is positive 1 between 0 and 2 pi. So our solution is just pi over 2. Specifically, since the previous factor over here did not give any additional solution. Okay, here's a new problem. Again, if we want to solve this like a quadratic, we want to set it equal to 0 so that we can use zero product property like we did here. So first thing to do here would be move our 1 over. Okay, now it's set equal to 0. We could use a u substitution here. We're going to let u equal sine of x again. So now we have 2u squared plus u minus 1 equals 0. Again, this is a quadratic. I believe it is factorable. Okay, so that factors as 2u minus 1 and u plus 1. And then we're going to set each equal to 0. Solving for u, we get u is 1/2 and u is negative 1. And then replace each u again with sine. So remember that u is represented by sine. So when is sine of x equal to 1/2? And when is sine of x equal to negative 1? So we can do the inverse sine of both sides. Okay, and now we're trying to figure out where is sine positive 1/2. Remember, sine is positive in the top two quadrants. And the 1/2 value that corresponds to sine is pi sixths. So our two values here should be pi 6, that's the value in the first quadrant, 5 pi 6, which is our value in quadrant 2. Where is sine negative 1? Well, that is the minimum value for sine, and that occurs at 3 pi halves down at the bottom of the y-axis. So our total answer has 3 solutions: pi 6, 5 pi 6, and 3 pi halves. Now again, you may not need to write this step, right? If you want to, you're looking for where does sine equal 1/2 and negative 1, you don't necessarily have to write this step to get to these answers. Okay, here's a new one. Same thing, we're factoring this in, trying to solve between 0 and 2 pi excluded. So again, I see a squared term, something to the first power, and a constant. I think this is like a quadratic, so let's set it equal to 0. I'm going to move everything to the left side of the equation here. Okay, so my equation is now set equal to 0. Let's do a u substitution. So u is going to equal cotangent of, and now we get a much nicer quadratic to solve here. So this one does factor, so we'd set each factor equal to, which just gives us -1 twice, and then of course replace u with cotangent. Take the inverse cotangent of both sides. Again, you might be able to skip this, and then we're really looking, where is cotangent -1? Well, remember, cotangent is the reciprocal of tangent. So if I take the value here and we did its reciprocal, we'd still end up with -1/1. So where is tangent -1? Can help us find those values. So we just did the reciprocal here. And where is tangent -1? Tangent is negative in the second and fourth quadrants, and -1 at the 45-degree angle away from each x-axis. So those two angle measurements are 3 pi-fourths for quadrant 2 and 7 pi-fourths in quadrant 4. Those are the only two places where tangent and cotangent are -1. Those are exactly reciprocals of one another. So again, we're relying on some unit circle knowledge to help us at the end here. Okay, here's another one. This time I noticed that there are only two terms. We don't have a constant itself floating around. But I do see we have cosine squared and cosine to the first, and it still might help us to visualize this using a u substitution. So if I let u equals cosine of x, this becomes 2u squared minus u root 3 equals 0. And in this case, because there's no constant, just like when we were solving the quadratic, we can factor out a common factor of u. So if we take out u as a common factor, it leaves us with 2u minus root 3. Okay, and then we do have two things we can set equal to 0, either u equals 0 or 2u minus root 3 equals 0. So solving each of those, for u, we get u equals 0, and u equals positive root 3 over 2. Add root 3 over, divide by 2. So plugging back in cosine, and then taking the inverse cosine of both sides. Where is cosine of x equal to 0? Well, that occurs at pi over 2 and 3 pi over 2. Over 2. And then where is cosine positive root 3 over 2? Well, cosine is positive on the right side of our unit circle. And root 3 over 2 corresponds to the pi over 6 denominator. So in the first quadrant, pi over 6. And in the fourth quadrant, 11 pi over 6. So these are the four values we end up getting for our solution. Okay, next example here. So here it looks like we have a mixture of sine and cosine, and again what we're going to try to do is set this equal to 0. So we're going to move this cosine over, okay, and then we are going to factor out a greatest common factor. Again, we can use a u substitution, might make it more obvious here, or you can notice that hopefully that both terms have at least one cosine of x. So I'm going to skip the u substitution this time. Okay, and dividing a cosine of x out of both, we end up getting sine squared of x minus 1 left over in our parentheses. And we're going to set each equal to 0. Solving on the equation here on the right, okay, we end up with sine of x equals plus or minus 1. So now we need to find all of our solutions. Where does cosine of x equal 0? That's again on the y-axis, pi over 2 and 3 pi over 2. And then where does sine of x equal positive 1 and negative 1? Well, sine of x equals positive 1 at the top, which would be pi over 2. Which actually, I just realized I wrote a 3 here. Pi over 2, which is actually already on our list, so we don't need to write it again twice. And where's sine negative 1? Well, that's also at 3 pi over 2. So we ended up getting some repeated solutions, which we don't necessarily need to repeat twice in our answer list. But this is both where cosine of x is 0 in both of these two values, and where sine is positive 1 and negative 1. All right, so here are some examples for you to try out. Okay, so Pause the video now, see if you can solve these four, and then the answers will pop up in a second. Be careful with number 9. Although 0 and pi might work for tangent, that makes cosecant undefined and therefore must be thrown out.